Types and models of machine learning. There are mainly three learning types: supervised, unsupervised, and reinforced. First, let's look into supervised learning. So in supervised learning, we have training data made up of a set of features that we'll refer to as X. In supervised learning, however, we always incorporate the proper labels. These are the Y's, as I just mentioned. Our model is trained using the features and the appropriate labels. Our model is then given new, previously unseen data made up only of features, and it uses this training to determine what the associated labels for each sample should be. As a result, we will receive the predicted labeled Y prime. In supervised learning, the model is supervised or assisted while learning. For example, we have a dataset of two variables, one being age, which is the input, and other being the shoe size as output. We could implement a supervised learning model to predict the shoe size of a person based on their age, like to predict the shoe size of a 10-year-old, referring back to the table. Let's move on to unsupervised learning. We have a collection of input data once more. We basically only have a set of features this time around because there are no labels. Our model is fed the data. The model generates results. In essence, what the model does is show structure in the input data. In this instance, Group A and Group B, or Cluster A and Cluster B, could be two groups or clusters of data. Examples in Cluster A will be related to one another in some way. It's time to take a deeper look into reinforcement learning. We have an agent which is effectively our model in reinforcement learning. The agent engages with its environment. A chessboard used in a game of chess is an example of an environment. At time t, a specific moment in time, the environment state is supplied into our model. The agent will suggest an action at time t based on the current state that it is provided. The action has an impact on and modifies the environment in some way. A chess piece being moved from one position to another might serve as an example of this. The environment will no longer be in the same state as it was as a result of this action. The agent is now once more fed the new state, the state at t+1. The agent is most importantly rewarded in proportion to how well its actions at time t change the environment in terms of the desired outcome, such as winning a game of chess. An intelligent agent that performs effectively in the new environment is the outcome of reinforcement learning. Let's look at a few of the most common machine learning model types that exist. The first one is regression. Regression is used to predict a real number such as the Y prime value of a property. We use a regression model, input a set of features, and the model predicts the label Y prime and connects it with the set of input features. So property of 200 square meters, 2 bedrooms, and 1 bathroom typically has a cheaper housing price which is around $75,000. Another property of a 700 square meter property with 4 bedrooms, 2 bathrooms, and a predicted value of $100,000. The value is higher. Recognizing regression as a model type is important since there are numerous approaches to build a regression model. Let's proceed to classification now. The process of classification requires making a probabilistic prediction of the class from a given collection. In this instance, we relate every input to a certain class. This is where our classification model comes in. It will take a set of features and correlate them with a certain class, like class A, with a corresponding probability, making it 98.17% certain that it belongs in class A. The first example might be connected to class B, the second to class A. If we use the same set of attributes that we used for the regression example in our previous example, properties in class A may be expected to increase in value, whereas properties in class B could be expected to decrease in value. A classification model can be created in a number of ways. Now let's explore clustering. When we cluster, we organize items into groups or clusters. We have a clustering model. Inputs, and we can create a large number of clusters by associating some inputs with cluster 1 and other inputs with cluster 2. Workers that behave nicely would fall into cluster 1, but misbehaving employees would fall into cluster 2. Let's quickly review the idea of transfer learning. Consider the case where we have a classifier model. There are several classifications in the classifier model, including person, cat, dog, and owl. A collection of training photos is used to train this model. This enables the model, for instance, to recognize different species of animals in pictures. We can make a copy of this classifier model and apply it to classify other objects. As an example, let's say we have 4 breeds of cats that we're interested in and we want to identify distinct sort of cats: Persian, Siamese, Munchkin, and Siberian cats. We can use the model slightly changed to develop a new classifier model, and then train this new classifier model using a collection of training photos. In this case, 3 things are crucial. The new classifier model is based on the old classifier model, which is the first factor. The second is that a group of categories has experienced a complete change. The third important aspect is that fewer training photos are typically needed to train the new classifier model than were needed to train the old one. These are the main benefits of transfer learning.